Hi guys, thank you so much Prabhakaran for your talk. This is going to be the last talk for the day, so don't want to bore you guys too much. After this, we'll be moving on to the build/networking session. So, hi guys, I'm back again. I'm Sabesh. I'm here to talk about fine-tuning models using MLX. I've given a talk before in the first edition of MLX Community Meetup, and that was about speculative decoding. For those of you interested, these videos are all published on our YouTube channel. I will link you to them later on. But yeah, this session is going to be on fine-tuning models. So yeah, let's get started. So MLX, typically you get started and you run it and you use it for inference. So you get answers for your prompts essentially. But the same MLX can be used for training as well, which is very cool in my opinion. Same framework, same machine, and it supports a bunch of fine-tuning options right out of the box. A few of these are LoRa, CLoRa, etc. We'll be talking more about LoRa today, which is low rank adaptation. The best part about this is the same machine that lets you do inferencing also becomes your training rig. And it's all in your backpack that you carry every day because it's just your MacBook. So I was asking myself the question, why even train? Because models in general know a bunch of things, and when you want to do domain specific use cases, you want model to be behaving a certain way. They don't sound like you, they don't know your style, they don't know your jargons, they don't match your format. The fix here was style transfer or domain adaptation, I would say. So you take a generic model and you give it a set of your examples, and then it learns a pattern from there, and then it learns how to respond, or it learns your jargons, or it learns your style. So use cases for it could be taking a model and adapting it to niche use cases, like maybe a legal firm, or maybe hospitals, medicine industry, etc. on a professional use cases. And on a personal use cases, maybe you want a bot to tweet like you, which is what I tried. So we'll get to it in a bit. So for this, we'll be using something called LoRa, like this is what I implemented. Why not fully fine tune? So for just brushing up on some basics of how neural networks work, you have a lot of layers in a neural network, and when you want to fine tune a model, you have to kind of train it again, and you have to dial all the knobs a little bit, and then this entire process is compute heavy and expensive, and if you're not very careful, you can do it the wrong way and just it will go really bad. So you have to really know what you're doing, and your data needs to be clean, and we need something lighter that can happen faster in lesser compute in your laptop per se, which is where we have LoRa. So it stands for low rank adaptation, and this is task specific updates that live in a low rank subspace. So what that means is, instead of updating all your weights, you only update a small number of weights, usually less than 1%. You tweak those parameters, and you guide it saying, okay, this is how you're supposed to behave. You reward it for that, and the premise is your entire model's few final layers learn this, and they kind of match your style or match your jargons, etc. So that was the whole premise behind LoRa, and a lot of companies, a lot of people use LoRa training to get models for their specific use cases. So instead of training fully, you do this, it's faster, it gets you really close to where you want to get, maybe not fully, but it does the job for you. So this is how it works. You have your pre-trained weights of a model, an open weighted model, and then you have a weight update, which is del W, which is going to be really small, and for every input, your inference is going to account in for the del W itself. So that's how LoRa works. And LoRa on MLX is a very delightful combination. It's very tiny. The process, it's not really compute heavy. So just your M2 MacBook Air for 16 GB can fine tune a 7B class model. And you don't have to do anything with servers, clouds, everything happens on device. And your iterations take minutes. And I think when I ran LoRa, it took me on an average close to 15-20 minutes, which is crazy. And best part about all of this is just that it's just one command to train your model. So the emphasis here would be on iterations, it would be on collecting data properly, etc. case study is Sabesh Twitter. So I tweet a lot on Twitter, and I thought, okay, some tweets performed well, like or X for the new generation. So some tweets performed better, and some tweets rather not well. So I thought, okay, what if I can take my Twitter data and take my top performing tweets and make a LoRa on that on top of a general purpose model? Will the model learn to tweet like me? This was my thesis basically. So I took a very small base model. It's 4 billion parameters, Qwen3 instruct. The instruct 2507 model was chosen in specific because in my research I found that this was a model that adapts well to training. And the data unfortunately is a very small subset because I realized not a lot of my tweets performed well, and 125 of my well performing tweets were taken, and I ran it through a simple command, and this is it. That's it. This is all I did. Okay, just kidding, not all, but it was days of iteration, days of cleanups, and trying to see if the results worked. But yeah, I'm just awed by how simple it is to fine tune your models. This specific class of fine tuning is called SFT. It's called supervised fine tuning, and that's what I did basically. So exactly what I ran. I will give you a gist of all the parameters used for people who are interested. So I took a bunch of these. This is basically the LoRa config that MLX uses. It ingests in this config, and then what happens is it fine tunes and creates an adapter. The adapter is basically your last final layers. So when you can do an operation called fuse, where you fuse the adapter with your main model, and then you can run inference. So yeah, we started with these very small LoRa parameters because it's a very small set of data, which I will get back to later in the presentation. So just a small video recording of the training process. I think it's not playing. It was supposed to play, but yeah, basically it just trains, and this is how the whole training process worked, wherein it just goes through every iteration and then saves checkpoints for say every 100 iterations, etc. So so some parameters here that you should be mindful of when you're doing it, if you're doing it, is your validation loss, which is supposed to drop down. So you train some and then you validate on some test data. So when you do that validation, you're supposed to see better results as and when the training happens based on your learning rate. So I achieved a val loss of 2.619, I think, at some iteration. And best part is it's the same laptop that I'm presenting in that trained the model. And yeah, so a bunch of my time went into tweaking and finding where I had the least validation loss, where training loss was lower but validation loss was still higher, which indicates overfitting. So I had to tweak a few knobs, some parameters in the config, get in more data if needed, things like that. So as you can see, it's this was my val loss graph as it reached I would say a local minima here at 2.61. So these are number of iterations, and what happens in your training process, it goes through all of these iterations. I set it to I think 600 iterations, and at this point it is crossed it and it's going a little bit up, which is not ideal. So what you'd want to save as the best adapter is this, wherever it got low. There were some gotchas obviously. There was some pollution in chat template because I used an instruct model. The model itself started spitting out think tokens without actually thinking anything. So this was something that happened, and the LoRa was like, fine, I will also do think. So every time I inferred, there was a thinking token which I had to strip down in post processing. The real caveat here was the data. So typically for LoRa, which I understood in hindsight, is you need a little bit more data than maybe 125 data points. Maybe something around the range of thousands is a good number to work with. But you don't want too much data as well, and in which case you might have to do a bit more sophisticated training mechanisms, maybe not LoRa. And yeah, your inference must mirror the training, which means what you do when you train is basically you ask it to autocomplete. So it will sometimes, which I will show in a demo, it will try to autocomplete my thoughts, which is not what we want. What I wanted was to type in my thoughts and for the model to output a tweet that will probably go viral in my taste. So But unfortunately, sometimes what happens is if you don't train it properly, it will just auto-complete your thoughts as well, which we don't want. But yeah, key takeaways from this: local inference and local training on your hardware, and MLX helps you do that. Training especially is a really cool thing that it offers help with. LoRa is the right tool if you have a small subset of data and you want a specific style that you want to transfer, or like a domain specific niche use case. Yeah, and I spent a sum total of $0, a few hours of my time and my laptop basically. Let me show you a demo before we start building. All right, let me. Was another. It's here. Perfect. So I've already trained and I have a bunch of adapters. I will be running one such thing. I have no idea what it's going to tweet because I've had several iterations. Sometimes it performed well, sometimes it was horrible. So let's see. I hope the demo gods are with us today. Yeah. The idea behind this Twitter bot is I give it some thought and it has to give me my style tweet that is supposed to perform well. So excuse me if there are some profanities on here. MLX India Chennai edition is going really well. It just outputted the same thing. So I'll say MLX Chennai is great. There's a large reason why we should talk about this at MLX Chennai. It was very fun to attend. I had no such plans for future events at MLX Chennai. So basically, it's just taking a bunch of my well-performing Twitter data and trying to find which tone matches how I would tweet, etc. So Model Hub is a great app. Really cool. I think this is something around the lines of what I would tweet. So you can see sometimes it performs well, sometimes it's like really horrible. So yeah, this was the whole thing. I can share more data with you guys later, but basically, like I said, there was some post processing on stripping out the thinking tags in the tool calls. But I had experimented with a few adapters here with some instruct models. But yeah, this was fine tuning with LoRa. Let me know if you guys have any questions. Yes.
What is the context? Because Bharathi and MLX Bharathi windows affect the immediate memory for training.
Fair enough. Let me check this. It's so your config has this. Yes, this is the sequence length. So this is how it would be trained. So in chunks of 512 tokens. Yes, but the inference context window is different. For training, this was the thing. Yes.
So how do you reduce the
Wait.
like Ball 2.6 is the architecture. So
Yes.
what has now changed?
So yes, there was some insights. I will have to check this, but basically, if it was overfitting, then what I did was I tweaked some parameters. I maybe ran it at a higher rank, or I had a. So basically, these are some LoRa parameters that can be used to train. But I only used the self attention key. So what I did in between was I took a few more tweets from other profiles as well. I took a few more data that I wanted to collect, and I added more layers basically, and I added more keys here as well that it will that the LoRa affects the LoRa the matrices were LoRa affects. So what I did was one such thing was I tried with MLP layers as well, which was not really performing well. I think I've landed on some optimal configuration here. Earlier it was a bit too the val loss was too high, and some things I configured here are the learning rate, the rank, the scale. So the rank basically tells at what, like the higher the rank, the more impact it will have on training. The scale tells you how much LoRa should affect the inference. So basically think of them as like some twin parameters. Usually the scale is twice the amount of rank, and yeah, like by tweaking this, I kind of sort of found a middle ground, you can say. But yeah, these are some. The config is where I played with the most, and yeah, as long as your data is right and data is like sanitized, I think you can play around with the config to find interesting results. Yes, it depends on the type of the model. So for dense models, you have to do differently. For MOA models, you have to have different parameters, etc. So I stuck on to just a couple of models, mostly just finalize with the instruct model because it was serving my purpose well. So yeah. Any more questions? Like yeah, on a ballpark. Like you saw, it's not for objectively changing everything a model knows about the world, but maybe to add a bit more information, maybe to add a bit more style, or let's say you take a generic Quen model that knows everything about the world. Say you take a huge model, 120 billion parameters. Now let's say you were to do a LoRa on it for medicine, and maybe it knows what drugs to use for what ailments, what diagnosis, etc. Maybe a hospital can leverage better out of it. Maybe. So it's not like it's only meant for that. It's not a specific model. It's still going to. You can still ask what is the capital of France, or some other things. But when you do ask it medicine related terms, it's going to perform exceptionally well. That's the thesis. And yeah. Bit more knowledge, a bit more style, a bit more domain, I would say. That is the main use case here. So guys, any more questions? Cool. I think sorted, right? All right. Thank you. Thank you so much. I'll go back to the presentation. Yes. What? Yeah. So now we have reached the end of the talks. We will start building, and I think the 3 p.m. is a little. We'll meet at around 3:30 p.m. I think that. For folks who are wondering what to build, you can build on your side projects. You can build on whatever you have ideas right now. As long as it fits in these 3 things, we are good. You can use MLX in any form, way, or factor that you like, and build something cool. I'm excited to see demos, showcases of anything that you've already built or building today at the end of today. So thank you so much. Please, I think it's like 1-2. Grab lunch at your own pacing. No constraint there. We're not able to offer all that here, but like please do. We are in like a good area, I would feel. So lunch is something that is subjective. So yeah, thank you guys. Thank you so much for attending. And yeah, let's start building.